5.5 is about theorems about roots of polynomial equations. Congratulations if you're listening to this right now. You do not need to copy this down. I was debating whether I want to talk about possible rational roots, but we're going to use our calculators tomorrow on this stuff. What are the rational roots of 2x cubed minus x squared plus 2x plus 5 equals 0? Again, use your calculator. We'll talk about those. And again, we talked about this a little bit before, but there's not much to do. Write it down. Talk about it tomorrow in class. Also, what are the rational roots of this? Same thing. And again, they're talking about rational root theorem. They want you to do plus or minus p over q. No need. I like calculators. Let's use them. Okay, conjugate root theorem. This you do need to copy down. If p of x is a polynomial with rational coefficients, then irrational roots of p of x equals 0 that have the form a plus radical b occur in conjugate pairs. What that means is it's a plus radical b, and it's also a minus radical b. And the same thing, a plus bi has to have a complex root of a minus bi to be able to be roots, because if it's there, i's got to disappear somehow. Same thing with the radical, it's got to disappear. So a quartic polynomial has rational coefficients, radical 2 and 1 plus I are roots of that. What are the other two roots? Okay, so it's pretty simple. Again, what's the opposite of radical 2? Well, radical 2, and it's got to have the conjugate, which is negative radical 2. And then 1 plus I has to have the conjugate of 1 minus I. Those are done. So here, it's much like your test. They're going to give you the roots. They want you to construct the polynomial. So it's what's third degree polynomial function y equals p of x, rational coefficient, so that p of x equals 0 has roots negative 4 and 2i. Well, if it has negative 4 as a root, what's that mean? That means that negative 4 is a root. It does not mean positive 4 is a root, but it does mean that x plus 4 is a factor. Okay, if 2i is a root, that means that x minus 2i is a root. And then again, if x minus 2i is a root, guess what? X plus 2i has to be a root as well to get rid of the I. Now, how I would start this is I would get rid of this first, the i's first or the radicals first, depending on what you have. It makes life easier. Again, FOIL. So leave x plus 4 in front. You get x squared. That's your outer. Inner is negative 2x. Outer is positive 2ix, I'm sorry. And again, that's going to cancel. And last is negative 4i squared. Well, going back to what i's were, okay, well, this is gone, so that's what we wanted to do. We get x plus 4 times x squared, and then you have minus 4i squared. But remember, because of I squared, we know that that really equals negative 1. Well, we have negative 4 here times negative 1, which gives me plus 4. So let's finish it off. Go ahead and FOIL again. First is x cubed. Outer is positive 4x. Inner is positive 4x squared. Last is positive 16. Now, you would go ahead and combine like terms, but there's nothing to combine here. So I got x cubed. Right in standard form, the next thing should be 4x squared plus 4x plus 16.